We are seeing something that is, truly an unprecedented act of industrial ambition.
Hmm.
In the name of AI, the world's richest companies are betting these staggering sums. We're talking trillions of dollars on turning huge chunks of the planet into these specialized data centers.
You're right. They're banking everything on this one idea.
That scaling compute power will just always inevitably lead to a profitable payoff.
And for you, the listener, this is a really intoxicating story right now. It's a simple narrative, isn't it?
Yeah, it is.
Smarter models mean more revenue, so you just keep pouring fuel on that fire. But beneath that, an uncomfortable phrase is starting to bubble up. The data center bubble.
Right.
So what we want to do today is really analyze the source material that lays out this collision, that, the potential of AI scaling versus the cold, hard, physical, and economic realities of the infrastructure you need to support it.
And that collision, that whole argument over whether this is a brilliant investment or, just insane, it's summed up perfectly by the views of three key figures in AI today. On one side, you have Demis Hassabis of Google DeepMind. He's all in, arguing we must push that to the maximum.
Then you've got IBM's CEO, Arvind Krishna, who has been, brutally running the numbers on what these data centers actually cost.
And his conclusion is pretty stark.
It is. He insists there is, and this is a quote, no way the current spending can pay off at today's costs.
And then, caught right in the middle, you have Anthropic's Dario Amodei. He's the one trying to navigate this massive capital commitment. And he talks about this huge, unavoidable cone of uncertainty around what future demand will even look like.
So that's the zone we're exploring. The tech gains from AI are real. They're undeniable. The critical question for you to understand, whether you're an investor or just like user of this tech, is can the economics and the physics things, as mundane as power grids and transformers, can they actually keep pace with these dreams?
We're looking for the hard limits.
We are.
Okay, let's unpack the specialized infrastructure first. What exactly is an AI data center? How is it fundamentally different from the cloud facilities we've been using for years?
Well, traditional centers are built for reliability and, general use. They're juggling web traffic, storage, databases.
Sort of like an efficient general-purpose warehouse.
Exactly. But AI centers are a completely different animal. The sources describe them as dense barns of accelerators.
Dense barns of accelerators.
Yeah, meaning they are packed floor to ceiling with powerful hardware GPUs, TPUs, other custom silicon, and they're wired together less like a flexible cloud and more like one single massive supercomputer.
So that whole mix of hardware, that's got to just completely change the game for the infrastructure, doesn't it? It sounds like they need a whole different caliber of support system.
It absolutely does.
Right.
And it really hits on three core issues that dictate the scale of this bubble risk. First is cooling.
Okay.
You just can't rely on big fans anymore. The compute is so dense, it generates so much heat that you often need these elaborate liquid cooling systems to manage the thermal load.
And that has to tie directly to power, right?
Precisely. These places are so hungry for electricity, they basically behave like a heavy industrial load. We're not talking about an office building. We're talking about a structure that needs its own dedicated substation.
Wow.
Drawing enough power for a small city. And the third issue, which is arguably the most frightening for investors, is the refresh cycle.
The refresh cycle, why is that so scary?
Because a slower chip, even one that's only a year or two old, it just loses its competitive value in the AI race.
So if your rival has faster hardware, their models will just leapfrog yours.
They get to market first. So misjudging demand doesn't just mean you have an empty building. It means you have billions of dollars in stranded assets, highly specialized hardware that you basically have to throw away and replace.
That is a huge risk.
The useful life of that capital is shrinking very, very fast.
Which dramatically raises the stakes. And it explains why site selection is such a high-stakes game. We see these AI centers popping up where electricity, climate, and politics all align perfectly. The sources point to growth corridors in Texas, Northern Europe using its cooler weather, and the Gulf states leveraging their cheap energy to try and get an edge.
And the pitch to local officials is always, jobs and tax revenue. But the real assumption driving all of this is that the boom will be matched by a decades-long tidal wave of demand.
And where does that incredible optimism come from?
It comes from the scaling laws. For more than a decade now, researchers have seen this simple, almost astonishing pattern. If you consistently increase a model size, the data it consumes, and the compute power you throw at it, the systems just reliably get better. At coding, at science, at finance, it just works.
And the scaling optimism is infectious. I mean, it almost feels like a law of nature now. Amodei from Anthropic notes that these laws, which once seemed speculative,
Yeah.
now feel routine.
And revenue is following that curve.
Exactly.
Yeah.
There's that internal anecdote from Anthropic where engineers are saying, I don't write any code anymore. I just let Claude write the first draft and I edit it.
That's not a small improvement. That's a massive leap in productivity.
It really is. And Demis Hassabis shares that vision. He sees scaling as the central path, something that has to be pushed to the maximum.
He's the one who thinks AGI might be just 5 to 10 years away, and scaling is how we'll get there.
Right. For him, the infrastructure build is just unnecessary risk on the way to this world-changing trillion-dollar prize.
But that's the essential point of divergence, isn't it? Hassabis is betting on that world-changing outcome, but Arvind Krishna is looking at the spreadsheets for the world we live in today.
He embodies that infrastructure pessimism.
He does. He's focusing on the cold, hard financial math. He estimated recently that filling just 1 gigawatt facility, which is, a pretty big campus,
Right.
costs roughly $80 billion in capital expenditure.
$80 billion for one campus.
For one, yeah. And if we follow the scenario of reaching 100 gigawatts of AI build-out globally, which many forecasts predict,
I can't even imagine that number.
you are staring down the barrel of $8 trillion in capex.
$8 trillion.
To put that in perspective, that's roughly the annual GDP of Japan.
That is just an astounding amount of money. How does Krishna even begin to factor in the risk on that?
Well, he calculates that if you just look at the interest payments on that scale of debt, the money needed just to service the capital, you would need about $800 billion of profit per year.
Per year.
Just to cover the borrowing costs before you even start paying down the principal.
Wow.
So his verdict is direct, and it's why he calls it a bubble. There is no way those investments pay off at today's infrastructure cost unless AI takes off far, far faster than current revenues suggest.
So what we're seeing is this collision point. You have the exponential math curves of AI models, and they are just slamming into the linear plotting reality of physical infrastructure.
Exactly. Grids, transformers, planning rules, they don't scale exponentially.
Right.
And that brings us right back to Amodei's cone of uncertainty. He has to commit billions today for power lines, real estate, chips, without knowing if his revenue in 2027 will be 20 billion or 50 billion.
And that timing lag between building it and getting the revenue, that's the mechanism that creates a bubble, isn't it?
It is. You overcommit today, hoping the exponential curve catches up before your very expensive physical assets become obsolete.
Okay, let's break down the actual costs driving this. We know the accelerators, the GPUs, the TPUs are the biggest single item. But as you said, they have the shortest useful life.
And that rapid obsolescence is lethal. Krishna's point really captures it. You have to throw it away and refill it.
You're forced into this perpetual, expensive refresh cycle.
Right. Not because the hardware stops working, but because if you don't upgrade, you lose the race. Those specialized chips instantly become a boat anchor if a competitor releases something twice as fast.
And it's not just the chips. You've got the buildings, the racks, the power infrastructure.
The expensive substations, the transformers, all the liquid cooling systems. And then you have to factor in the operational expenses, the OPEX, which is driven by electricity contracts, and increasingly water usage.
Let's talk about another risk the sources highlight. These vendor-financed chip deals.
Ah, yes. This is where a chip maker invests in an AI startup, and the startup then commits to spending that capital, buying chips back from that same vendor.
It looks like a win-win on the surface.
It spreads the risk, but it also ties them together. If the bubble pops, the whole financial structure can collapse. It's like the landlord giving the tenant a massive loan that can only be used to pay rent back to the landlord.
A financial house of cards built right up against these hard physical limits, energy, power, and water. The scale is it's difficult to grasp.
It is. A single major training cluster behaves like a steel mill or an aluminum smelter. AI data center power consumption is growing faster than almost anything else on the planet. This isn't a niche IT problem anymore.
It's a central grid planning problem.
Right. Planners are scrambling to figure out how to route power for facilities that might not even break ground for years.
And the water usage? That's now becoming politically sensitive, which just slows everything down.
Absolutely. High-density cooling requires a lot of water. In dry regions, that becomes a major headline. It's a political cost.
Local residents start asking questions.
And rightly so. They ask, why should our town stress its aquifers and put up with construction traffic and generator tests at night, also a distant company can train its models?
And that environmental pushback, it's not fatal on its own, but it injects more uncertainty, slows down
And
permits,
feeds right back into the economics of the whole build-out. It just adds to the risk.
which brings us back to the huge risk of overbuild caused by that timing gap you mentioned. On paper, the demand models look incredible.
They do. Consultants have charts showing demand climbing like a staircase. And Amodei's internal experience with revenue jumping so fast, it validates the bullish case.
But the real danger is synchronization.
Exactly. If everyone, Microsoft, Google, Amazon, Oracle, Meta, if they all assume that straight-line growth will continue forever and they all build simultaneously.
The market ends up with way too much capacity if that growth line bends even slightly downward.
That is the textbook definition of a bubble. And the consequence, when it unwinds, is rarely gentle. The capacity doesn't just disappear.
No, it becomes toxic debt for the losers.
And it changes hands at distressed fire sale prices. The weaker, highly leveraged players who bet everything on that climb, they fail.
And this is all made worse by that local friction we just touched on. A new facility isn't just a dot on a map. It's dust, it's traffic, it's generator tests at 3 in the morning.
And communities are asking tough questions. Who pays for the grid upgrades? There's also a clear climate contradiction.
How so?
Well, a city that just promised deep emission cuts might not be thrilled about hosting another massive fossil-heavy power consumer built to serve some distant company's training runs.
So that friction slows things down, makes permits stricter.
And ultimately feeds back into the rising cost, and thus the bubble risk of the whole endeavor.
So, given all this, what should the key players be doing right now? For governments, what's the takeaway?
The article argues they must treat these AI data centers like critical infrastructure. This isn't just a shed full of computers anymore.
So they need to demand clear cost breakdowns.
Credible plans for power that match realistic grid expansion, not just aspirational ones, and hard limits on water use in stressed areas. And communities have to share in the financial upside.
And for enterprises, the ones who will be customers of all this.
For you, if you're running a business, the risk is vendor lock-in. Betting everything on one cloud provider means you inherit their entire risk curve.
Right. If they overbuild or stumble, you're stuck.
A multi-provider strategy with clear exit routes is essential. Don't get stuck on a sinking ship if a vendor miscalculates their own $80 billion commitment.
Then for investors,
The job is to ruthlessly separate the structural opportunity from the narrative hype. Don't just look at the glossy claims about global AI power use.
you need to inspect the quiet details.
Exactly. Look at long-term power contracts, verify actual occupancy rates, demand real profit margins. Some of these companies will own the indispensable capacity of the future. Others will be left with stranded sites and a mountain of debt.
So looking ahead, it seems like all three leaders agree that AI will keep getting dramatically better. They just disagree sharply on the cost, the timeline, and the best route to get there.
Amodei has that compelling high-end vision of future models that are like a country of geniuses in a data center working just for you.
While Krishna, the skeptic, looks at the math and puts the chance of today's scaling path reaching true AGI at, what was it?
A mere 0 to 1%, and the data center bubble lives right in that overlap. It's the zone where those world-changing dreams meet the hard, linear limits of land, power, water, and capital.
It's a frictional zone you just can't afford to ignore no matter who you are.
Exactly.
And here's where it gets really interesting, a provocative thought for you to take away. Bubbles are not only stories of excess and financial destruction.
That's a great point.
They are also necessarily stories about infrastructure that later generations can and do repurpose. Think about the rail lines built during the 19th century bubble, or the fiber optics laid during the dot-com boom.
That infrastructure eventually finds a use.
Right. So the choice we have now is whether we steer the outcome by being specific in how we build, how we regulate, and how we invest, or whether we just ride along and let speculative excess decide if Krishna's pessimistic math comes true.
Either way, this infrastructural pressure point is the single biggest factor that will shape how AI actually lands in the real world, and at what cost. So keep exploring these intersecting themes.